Hello everyone, welcome to our unit on exponents. Let's begin with some vocabulary. First of all, a coefficient. A coefficient is a number multiplied by a variable. A base is a number or variable raised to a power. For example, in 2 to the third power, 2 is my base. This expression tells me that the 2 is multiplied times itself 3 times. Okay, that brings us to an exponent. An exponent is a number that tells how many times to multiply a base. So again, in 2 to the third power, 3 is the exponent. It is telling us to multiply 2 times 2 times 2. Sorry about that. So this expression is telling us to multiply 2 times 2 times 2. Okay, let's look at some other examples. In example 1, our coefficient is 3. The 3 is multiplied times the x to the fifth. Our base is x. X is raised to the fifth power, which means it's going to be multiplied 5 times. And our exponent is 5. So again, our coefficient is 3. Our base is x, and our exponent is 5. Okay, let's look at our second expression. Our second expression obviously has a base, that would be x, and it has an exponent, which would be -2. And we'll talk in a second about what a negative exponent means. But does it have a coefficient? Yes, it does have a coefficient. The coefficient would be 1. Anytime we don't see a coefficient in front of a variable, we can put the number 1 as the coefficient. So our coefficient here would be 1. So our coefficient is 1. Our base is x because it's raised to the -2 power, and our exponent is -2. So let's talk about what a negative exponent means. We already said that an exponent is a number that tells how many times to multiply a base. A negative exponent is going to tell us how many times to divide a base, or to divide by a base. So we could change this expression here to, instead of 1 times x to the minus 2 power, we could change it to 1 times x to the second power. This expression is telling us to divide by x 2 times. In other words, 1 over x times x. Divide by x 2 times. So that's basically the meaning of a negative exponent. Okay, let's move on to some exponent laws. First, we have the zero exponent law, which tells us that anything raised to the power of 0 equals 1. This law is actually really helpful to us in simplifying expressions with exponents. Let's do some examples. For example, example 1, x raised to the 0 power. Because the x is raised to the 0 power, it's always going to be equal to 1. Doesn't matter what number we plug in there for x, x raised to the 0 power will always be 1. Okay, example 2. We have the quantity 5x squared raised to the 0 power. Because the whole thing is raised to the 0 power, it's equal to 1. Okay, let's look at our next example. In the next example, the only thing not raised to the 0 power is the 6. Everything else, this expression in parentheses here, is raised to the 0 power. So that expression will be equal to 1. Bring down the 6 because it's not raised to the 0 power. Then everything in the parentheses is equal to 1. 6 times 1 equals 6. So you can see how we simplified a very long exponential expression into just one number by applying the zero exponent rule. Okay, we will do the my turn problems for zero exponents in class. Let's go on to the negative exponents rule. I'm going to go to the Purple Math website for this rule because I really like their definition. It says that a negative exponent means that the base is on the wrong side of the fraction line. So you need to flip the base to the other side. So a negative exponent means the base is on the wrong side of the fraction line. So what are we supposed to do to make that negative exponent positive? Well, the Purple Math website says to flip the base to the other side of the fraction line. So what we'll need to do is we'll need to flip the base to the other side. Okay, so let's do some examples. So 4 to the negative 1 is telling us that the base 4 is on the wrong side of the fraction line, and we need to flip it to the other side of the fraction line. So 4 to the negative 1 is going to become something over 4 to the first power. Now we need to hold this place here. So since there's nothing to hold the place in the numerator, we'll put a 1. So 4 to the negative 1 power becomes 1 over 4 to the first power. We flipped the base to the other side, and we made the exponent positive. Okay, how about in example 2? 3x raised to the negative 2 power. So again, this negative exponent is telling us that our base is on the wrong side of the fraction line. So we need to flip it to the other side of the fraction line. So we'll put it in the denominator, and we'll make the exponent positive. Again, we need something to hold our place up here. So we'll put a 1 to hold the place in the numerator. Okay, let's look carefully at example 3. First of all, we need to understand which number the exponent, that negative exponent, applies to. An exponent only applies to the number or expression that it touches. The negative 2 is touching that x. So then that negative 2 only applies to the x. It does not apply to the 3. So the 3 is going to stay in the numerator while the x goes down to the denominator. Notice we also have another negative exponent. We have y to the negative 4th. So that y to the negative 4th is going to have to flip to the other side of the fraction line and come up to the numerator. So let's see what our new expression is going to look like. The 3 is going to stay in its spot. X to the minus 2 is going to flip to the bottom of the fraction, and this 2 is going to become positive. Y to the negative 4 is going to flip to the top of the fraction, and the 4 is going to become positive. Okay, one more example. Again, let's make sure we pay attention to what our exponents apply to. This 2 is a positive exponent. It applies to the 3, so that is staying in its place. The negative 1 applies to the u, so we know that the negative 1 is going to have to flip to the bottom. The u to the negative 1 is going to have to flip to the bottom of the fraction. The v to the negative 2 will also have to flip to the bottom of the fraction. So what will our new fraction look like? The 3 squared stays on top because the exponent is positive. U to the negative 1 flips to the bottom, and the 1 becomes positive. V to the negative 2 flips to the bottom, and the 2 becomes positive. Can we simplify this fraction in any way? Well, yes, we know that 3 squared equals 9. So we can rewrite this as 9 over u to the 1 v squared. Again, we'll work on the my turn problems in class together.